The GS20 family of drives have two operating modes, the traditional speed control mode and torque control mode. We know the power of a rotating body is torque times speed. So when the drive is trying to achieve some speed, it can play with the power and torque to get there. And when the drive wants to achieve some torque value, it can manipulate the speed and the power, which is really the frequency, current, and voltage. The problem is, while the drive can definitely manipulate the voltage and current, it doesn't really know anything about the speed of the motor. But it can estimate the speed of the motor by the way the voltage and current react if it knows some things about the motor, like the no-load current, the stator resistance, the rotor resistance, the magnetizing inductance, and the stator inductance. And the good news is, the GS20 drives can automatically measure all of that stuff for us. Let's do it. I'll reset the drive to factory default and power cycle it so you know exactly where I'm starting from. I'm assuming you know how to enter parameters, so I'll fast forward through entering all of the basic motor parameters. Great. The drive now knows the basics of our motor. To get the measured values, we just go to parameter 5.0 and set it to a 1 to tell the drive to do a dynamic tuning and hit run. This takes about 2 minutes, so I'll bring up a timer so you can see when things happen while I speed up the video. So the motor held still for this long. I could actually feel it humming during that time. And then it ran for this long, and then it held still for a while longer. I'll bring up the parameters in the free GSoft 2 app, and we see these are the values it measured. Great! Now the drive has everything it needs to estimate the speed of the motor so it can calculate the torque. We can now put the drive in torque mode by going to parameter 0.10 and setting it to a 2. Now the drive's goal is to maintain a torque value we enter and manipulate the speed and the power to do it. I connected a wire to this 2.5-inch radius pulley and a 4.8-pound weight to the other end of the wire. I'm using a wire and not a string because it doesn't stretch. If this stretches, it adds an extra dynamic that we have to account for, and we don't need to be messing with that in this quick start video. Our goal is to have the drive apply exactly the right amount of torque to hold this 4.8-pound weight at whatever position we move it to. Of course, at zero torque, the weight just drops. We know torque is radius times the weight, and this happens to come out to 1 foot-pound. The motor's nameplate tells me the rated torque is 3 foot-pounds. So if we tell the drive to generate a third of that, or 1 foot-pound, it should hold the weight, right? If we go to parameter 11.34, we see the torque is currently 0%. I'll hit run, and yep, the weight doesn't move. Let's enter 25% of max torque value. Now that should not be enough to hold the weight either, right? Yep, the motor can't pull the weight up or hold it in place. How about 30% torque? That should get us closer. Nope, still not enough torque. Okay, how about a third? Now the drive's really close to holding the weight, but we're not quite there yet. So I'll bump the torque up a little bit until it's more solid. And yep, now the drive holds the weight. If I move it up here, it holds. If I move it down here, it holds. And if I move it back to the middle, yep, it holds. How cool is that? The drive is doing exactly what we want it to do. If I bring up GSoft 2 scope function, we can see that in action. We can see we asked for this much torque, the drive is actually applying this much torque, and the frequency and the current are running around here. If I move the weight, we see the drive modify the frequency to try and compensate. Exactly what we expect to see. Let's move the weight to the bottom and stop the drive. I'll hit run, and I've actually got a little too much torque in here. Let me adjust that back down a little bit and steady the weight. And I'll stop the scope and zoom in, and we can see where the drive took the initial slack out of the wire, and when things tightened up, the torque ramped up and eventually settled out at the holding value we needed by adjusting the current and the frequency of the drive. Exactly what we said it needed to do at the start of this video. How about that? So that's the basics of getting torque mode running. There's a great diagram in parameter 0.10's description that shows you all of the available options when running in torque mode. We manually entered the torque we wanted in parameter 11.34, but it can come from the 485 input, the analog input, or even a COM card. You can specify how to limit the frequency. You can add torque bias from several different sources, set a max torque, limit the torque in all 4 quadrants, add automatic speed regulation, and all of the usual drive control stuff. Leave us a comment below the video if you would like to see more videos covering how to use those torque mode options. Meanwhile, click here to see all of the GS20 variable frequency drive video tutorials. Click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support options.